All right, so 6-4, let's try to finish it. Call it C. And what was the last thing we were talking about? What figure? The whole thing is called, I didn't write what the whole thing is called, but it's called what? Let me see what it's called. Rectangles, rhombi, and what? And squares. Yeah. So, let's see. I really don't even talk about squares much on here. Let's see. Rectangle. Why in my notes I don't even mention a square? Well, I'll talk about it, but I don't know why it's not in my notes. I'm looking. Nope, I see nothing about a square. Well, make sure we talk about a square before we get done. Really, to tell you the truth, there's really nothing new about a square because a square is basically, it's a parallelogram. So everything that's true about a parallelogram is true about a square. Plus a square is a what? A rectangle. So everything that's true about a rectangle is true about it. And a square is also a what? A rhombus. So everything that's true about a rhombus is true about a square. So really, there's no like special theorems or anything like that about a square because a square is all three of those things. Okay, so that's why we don't have anything about a square. But we do have something about this rhombus. So let me try to draw a rhombus. And now when I angle it like this, that changes. It makes that side longer than that side. So I got us. Does that look like those two sides are equal? Like all four sides are equal? Pretty close. Pretty close. All right, let's throw some diagonals in there as well. Now we've already learned about the rhombus, but let's review quickly before we do this example. Okay, we're going to put some numbers in here and solve for missing angles, missing sides, blah, 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 right? We do this all the time, don't we? Right? We just do it with different pictures, that's all. Just different figures, that's all. All right, so what do we know? This is a rhombus. This, they tell me. Now, there's no special, like, symbol for a rhombus, so we just write what? Rhombus. Now, there are four sides, so we're going to call it rhombus what? A, B, C, D. So this is what they tell you. All right. Sometimes they'll put the word given, sometimes they won't. I'll put it. All right. So it's given that this is a rhombus. So if I know that that thing's a rhombus, they tell me it's a rhombus, then what do I know about A, B, and D, C? Actually, all four of them are equal, right? Because that's the definition of a rhombus. Agreed? So let's mark it. So boom, 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 boom. All right. And what about the angles? What about the opposite angles? Big angle A and big angle C. What are they? They're equal to each other because the opposite angles are equal, right? The opposite angles are equal in a parallelogram, so the opposite angles must be equal in a what? Rhombus as well, because a rhombus is a parallelogram. Everybody got that? All right, what about angle B and angle D? The whole big angle B, the whole big angle D. They're equal to each other as well, okay? What about big angle A and big angle D? What's the relationship there? They add up to 180 or they're supplementary. Same thing, okay? They're supplementary to each other. I think that's it, but now we got to deal with the diagonals. Okay, what's true about the diagonals in general? They bisect each other, okay? So A, whatever this letter is, I don't put it letter there, but we'll call it M. So AM and CM are equal to each other. DM and BM are equal to each other, okay? Now, are the diagonals necessarily equal to each other on a rhombus? Now, the way I asked the question, you probably knew that it would be a no. Wouldn't you agree? All right, so when are the diagonals equal to each other? When it's a what? When it's a rectangle. Or, what was the thing we talked about earlier? When it's a square, okay? But on just a regular old rhombus, okay, without right angles, the diagonals are not equal to each other, but they do something. What happens? There is a relationship between the two diagonals. They're perpendicular. Very good. Okay, so they are perpendicular to each other. Okay. They do something to the angles as well, don't they? They bisect the angles. This is the first time we talked about the diagonals really doing anything to the angles, right? And they bisect the angles. So this little angle here, this one here are equal, this one and this one. In fact, look, since B and D are equal to each other and they're both being bisected, What's true about this, and this angle? They're all equal to each other, okay? And what's true about 1, 2, 3, 4 right here? They're all equal to each other. Does that mean that these 4 are equal to these 4? No. It just means these 4 are equal to each other, and these 4 right here are equal to each other. Everybody got that? All right. I think we've exhausted everything we know up to this point about a rhombus. Would you agree? Yeah. So hopefully, what they give you, you should be able to figure out. So they give you some angles, and then they ask you a bunch of stuff about those angles. So we're going to, instead of calling this angle like BAC, right? That's kind of a pain, isn't it, to look like that? They make it a little easier, and they just call that angle 3. They call this angle 1. They call this one 2. They call this one 4. And this one is 34 degrees. Now, obviously, that 4 doesn't mean it's 4 degrees. Everybody understand that? All right, the 2 is not 2 degrees. It just is the name of the angle. It's just an easier way. So if I just said angle 3, isn't that a lot easier than me saying angle BAC or angle CAB? Yeah, so that's why they do that. Okay, enough of that. Let's push this off to the side just a little bit. Give me some room to write over here. All right, so there's 6 parts to this. Some are easier than others. I'm going to do it like this, A, B, and C, and put D right here, E right here, and F right there. So what do they ask you? They ask you for angle 1. They ask you for angle 2. They ask you for angle BAD. This one's angle 3. This one's ABC, angle ABC. And this one is angle 4. All right? So that they want you to find all this stuff. Well, let's start with angle 1. Angle 1 is probably the easiest thing to find out of the whole thing, isn't it? Or one of the easiest ones. What's angle 1? What? I thought you would get it right away. Boom, you should get it, just like that. What's angle 1? Huh? 146? What is it? Why is it 90?
Oh, yeah.
Yeah, you don't even have to know what that one is, but you do know it's a rhombus, and you know the diagonals are what? Perpendicular to each other. Agreed? So right off the bat, that's 90 degrees. Everybody with me? All right. What about angle 2? Where's angle 2? This little skinny one right here. Oh, that's just as easy as that one. What is it? It's 34. Why is it 34? That's right, because remember, this diagonal does what to that big angle C? Say it. Bisects it. That's right. Splits it in half, right? So if this is 34, then this has to be what? 34. Okay? Everybody getting that? This is actually kind of fun, isn't it? Trying to find out what all the missing stuff is. Almost like a little game. Think of it as a little game. It's kind of fun. I don't know. Maybe it is to you. Maybe it's not. Angle BAD. This old. So what's BAD? That big old bad angle right there. BAD. Yeah, how'd you get 68? Well, how do you know it's 34 and 34? Perpendicular doesn't have anything to do with it. It's equal to this angle down here. That's right. Remember earlier we said this one, and this one are all the same? So that means this is 34, that's 34, then altogether it's what? 68. And degrees. Put the degree symbol. Okay? On your quizzes, a lot of people were forgetting to put degrees. I think the first 2. All the rest of them put a little blank, and if it was an angle, I actually put a little degree symbol there, so you didn't have to actually do it because I already put the degree there. But make sure if it's an angle, always put degrees. All right, let's keep going. This is pretty easy so far, isn't it? Yeah. Well, part D is just as easy. What's angle 3 going to equal? That's going to be 34 degrees, okay? I could have written it in here, but that's 34 and that's 34. So that's easy. ABC, ABC, that's this one right here. Okay, now we're talking. Now we're getting a little bit more complicated. Not much. Tell you what, let's go different color. That big angle right there. Talk to me. How'd you get 112? Very good. I like that. It's supplementary to angle C. It's exactly the way I wanted to hear it. See these two angles right there? They're supplementary. You talked about that earlier, right? When we went through all the stuff that's true about the rhombus. They're supplementary, which means what? What does it mean to be supplementary? It means they add up to 180. So if I already know this one, which is what? 68, right? I take 180 and I do what? Subtract 168, okay? And that's what?
You just mean 68?
That's exactly what I mean. Why did I write that? I don't know. I was thinking of the answer. It's minus 68, and that's what? 112, right? So it's 112 degrees. Probably the hardest one of the whole thing, right?
Yeah.
Now, once you know that whole thing is 112, that shouldn't be that hard to find. So how do I find that? 112, do what to it? Say it. You got it. Divided by 2. And what is that? It's 56. So that's 56 what? Degrees. And then there you go. And the game is over, right? It's kind of a fun game, wasn't it?
No. Yeah, no.
Yeah, it was.
I'm joking. It was fun. It was fun. I like that.
It was kind of cool. And this isn't just any old math. This is like, you really have to think a little bit, right? If all I said was, what's 180 minus 68? That wouldn't be fun. That's boring. That's just nothing, right? But here it's like, that's equal to that. That's equal to that. Oh, and that's supplementary. Oh, yeah. You know what I'm saying?
Yeah.
All right, that's kind of what I do, right? I'm thinking that kind of stuff. I'm like, oh, yeah, now I see it. To me, it's kind of fun. That's why I like geometry. But anyway, what?
I like how you record your videos.
Good.
But then I watch them.
Good.
Because like, I sometimes, I know I don't pay attention to a lot of class, but when I get home, bro, I watch your videos, bro.
Okay, good.
I'm your number one supporter. Not your bro.
I appreciate your support.
Yeah, you're welcome. You're a very good teacher. But I'm not your bro.
All right, here we go. Let's see this. Okay. Do you remember we said if it's a rectangle, then all this stuff is true? For instance, if it's a rectangle, what do we know about the diagonals? They're equal to each other, exactly. Okay, everybody understand that? Do you remember we did this not too long ago? We took the if and then, and what did we do with it? We switched them, okay? So you don't have to write this part right here, but before it said if a trying to think of how I should say this. If a quadrilateral is a rectangle, this is not the new theorem. This is an old one, okay? So don't write this one down. You can if you want. I don't care. But this is not the new theorem, okay? This is an old one. This is the first if-then. And then after that, we're going to switch the if-then. Is that all right? So this is the first if-then. So if a quadrilateral is a rectangle, then what do we know about the diagonals? Then the diagonals, right, are equal or congruent, whatever you want to say. I don't care. Everybody got that? So we already knew that. So let's draw a picture. Oops, wrong button. That's what I want right there. So if I told you that this was a rectangle, all right, by definition, it had all 4 right angles. Okay? If it's a rectangle, then what did we learn earlier about the diagonals? That they're equal to each other. But what do you think the theorem that we're going to learn right now says? Do you remember the P then Q? Remember that? The P is the if part. The Q is the what? The then part. So let's switch and let's go if Q, then P. That's right. If the diagonals, and let's just be a little more specific, if the diagonals, they say of a parallelogram, I think you could say of a quadrilateral, but it doesn't matter. So if the diagonals of a, let's just say quadrilateral, they say parallelogram, but I think, if I'm not mistaken, I think we're okay, because if the diagonals of any quadrilateral are equal to each other, it has to be a rectangle. So anyway, if the diagonals of a quadrilateral are what? Are equal to each other, then what is that figure? Then it's a what? It's a rectangle. Do you see the difference? All right, it's a subtle difference, but it's definitely a difference because we completely switch the if-then statements. Instead of going if P then Q, we change it around and go what? If Q then P. By the way, we give that a name. The if Q then P, we call the converse of the statement. All right? We talked about this before, but if I was going to do like a full-blown geometry class and teach you every possible thing I could about high school geometry, we would definitely cover this stuff. But we just don't have enough time to cover everything. All right, there's some things I think are probably more important that we want to cover later. But this is in that thing that I probably skip, okay? But that's the converse of it. So what does this say? It says, if the diagonals, let's do this. Let's say I don't know that these are right angles. But let's do this. A, B, C, and D. What if I told you that AC was equal to BD? All right, so that's all I tell you. I give you four sides, I give you diagonals, and I tell you that AC and BD are equal to each other. Then what kind of figure is this then? It's a rectangle. So if it's a rectangle, then what could I say about angle A? It's a right angle. And then angle B and C and D are all right angles as well. Do you see the difference? Again, it's kind of subtle. Sometimes people look at this and like, Mr. Henry, you're basically saying the same thing as you did before. Not really. Kind of, but not really. All right, so if I just look at this and I don't know what it is, all right, but I know I got four sides and I see the diagonals, and if I knew that the diagonals were exactly the same, I could tell you that this thing is a rectangle. That's what the theorem says. That's our theorem. Everybody got it? Okay, let's do another one. Same thing. I'm not going to go through that whole routine again, but let's just see if it makes sense. So I'm going to draw this picture. And let's slant it just a little bit. Make it look more like what we're used to seeing. All right. Now, it kind of looks like a what? A rhombus, okay? But we don't know for sure. Okay, I don't know that that and that are exactly equal to each other or anything else. But what if they told me this? And let's do this. What if I knew that this diagonal was perpendicular to this diagonal? Now remember, I don't know at the beginning that this is a rhombus. Are you with me? I don't know it's a rhombus, but I do know, they tell me, it's given that these diagonals are perpendicular to each other. If that's the only thing they told me, now what can you say about that quadrilateral? It's a rhombus now, okay? So if the diagonals are perpendicular to each other of a quadrilateral, then that thing has got to be a rhombus. If it's a rhombus, then I know a whole bunch of other stuff, don't I? I know the side, all the sides are equal. I know the opposite angles are equal. I know the diagonals bisect the opposite angles. I know all that stuff, okay? So just by knowing that the diagonals were perpendicular, that's enough to tell me that that thing is a rhombus. You good with that? Okay. And the rest of them are all the same thing. It seems like we've done this before, and we kind of have, but we're flipping the P and the Q, right? Let's go back to white. All right, let's see what the next one is. Oh, you know what the other one was? Let's just keep that picture. What if this, get rid of that, get rid of that. Okay, so right now, do you know anything about this? No, you just know you got a four-sided figure and you got diagonals. That's it. That's all you know. You don't know when anything's equal to each other, right? Because I haven't marked anything equal to each other. But what if you knew this? The diagonals congruent. Okay, we did that one. Let me see. Okay, bisects pair of opposite angles. So watch this. What if I knew that that and that were equal? And what if I knew that that one and that one were equal? Okay. And what if I knew that this and this were equal? And what if I knew that this one and this one were equal? So what if I knew all that information right there? Now what can you tell me about that figure? It's a what? It's a rhombus. That's right. Because if the diagonals bisect the opposite pairs of angles, then it's a rhombus. What did we say earlier when we first learned about a rhombus? We said if it's a rhombus, then the diagonals bisect opposite pairs of angles. Agreed? What are we saying today? If you have a four-sided figure, quadrilateral, and the diagonals bisect the opposite angles, then what is the figure? It's a rhombus. Okay. I feel like I'm beating a dead horse here. Everybody got it? But sometimes I just got to say things a whole bunch of times, right? Don't you think? Sometimes the second or third time you hear it, you're like, oh, now I understand what he keeps harping about. Okay, let's do another one. A couple more. Let's see. Oh, okay. This is a little different. I don't think we did this. Let's go to white. Come on, click on it. There we go. Let me draw a thing that kind of looks like a rhombus again. All right. Again, I'm going to make it look like a rhombus because eventually it's going to be a rhombus, okay? But right now, just sitting there right now, do I know that that's a rhombus? Nope, don't know anything about it. Nobody told me it was a rhombus, but you do know that it's a parallelogram, okay? So they tell you that it is a parallelogram, all right? And it says if two consecutive sides of a parallelogram are equal to each other. So I tell you what, let's draw this, and let's draw like your quote normal parallelogram, if there is a normal parallelogram. So let's copy and paste that. Let's push this down here. Let's just do this. Okay. Not yet. So let's take a look at this. This says if two consecutive sides of a parallelogram, well, what are the consecutive? Not this one and this one. What would the top one and the bottom one be? They wouldn't be consecutive sides. They'd be what? Opposite sides. So what's this side right here and this one right next to it? They connect. They would be what? Consecutive sides. So if two consecutive sides of a parallelogram are equal to each other, then what do you think is true about this? It's a rhombus. Now, why is that? Let's do a little mini proof of it. Remember, they told you it was a parallelogram, okay? Not just any old quadrilateral. They told you it was a parallelogram. So if it's a parallelogram, what's true about the opposite sides? They're equal. So if the consecutive sides are equal, and this side are equal, and this side are equal, everybody see that? Then all four sides are equal, therefore it's a rhombus. We good? Yeah. All right. Notice, it's not going to happen on your everyday normal parallelogram because look, this side and this side are not equal to each other. It could still be a parallelogram, correct? All right, but it's only a rhombus if I take this side and move it in until what? Does that look about right? Until what? Until this and this are equal. Okay? Everybody got it? Yeah. Okay. Let's do one more and then we'll quit. Then you can go to the bathroom. Yeah, this is pretty basic. It's almost like self-explanatory. Not self-explanatory. It's just like common sense, I guess, if you want to think of it like. It says, two parallel lines are equidistant everywhere amongst these parallel lines. So what in the world does that mean? So these two lines are parallel. We've talked about this. It's been a little while, but we've talked about this. What would the distance from this point of this parallel line to this parallel line be? Let's do a different color. Is that the distance from the one parallel line to the other? Is that the distance? Is it from there to there? Where is it? It's where? It's from here. It's the altitude. Good. I like that. It's from here where? Give me a word. Let's say straight down. Perpendicular. Perpendicular. That's exactly right. And, Tristan, you're absolutely right. It is an altitude. All right? So the theorem says this. It says two parallel lines are equidistant everywhere. All right? That's basically what it's saying. So this distance is going to equal this distance. And what has to be true about both distances? They have to be what? Perpendicular. So if this has one tick mark, and that's perpendicular between two parallel lines, then how many tick marks do I put on this one? One, because they're equal to each other. I could do this all day long, couldn't I? All right, and what's going to be, whoops, can't do that. Watch. What's going to be true, if it's perpendicular, what's going to be true about all three of these red lines? They're all going to be equal, and I could keep doing that forever. Everybody got that? Now, what if your lines were not parallel? Is that going to be true? Let me just show you. I mean, you could probably envision it, right? There's two lines that are not parallel. Agreed? Oops. Watch. If I went from here perpendicular to that, then I went from here perpendicular to that, are they equal to each other? Okay, no, they're not. So what's the only way that these two lines right here are going to be equal to each other when what? This line is parallel to this line. Again, that's common sense, isn't it? Yeah, a little bit. All right, that's all the stuff that I have to teach you today. So you are going to do section 6-4, and it's pages 272, 273, and it's just 1 to 11. That's not that many at all. Give me a pass. There's your homework, okay? And that will be due on when? Tuesday. You have off on Monday, okay? Enjoy your day off. I will not enjoy my day off because I'll be at the dentist getting a crown on my tooth. So I have a temporary, I got a temporary one right here, but they got to put a permanent one on. So that's my fun day off, going to the dentist. So you guys have a good time for me. Hopefully.